Hello and welcome to Badger Talks Quick Picks, which bring exciting happenings, resources, and talent from your UW flagship campus to the people of Wisconsin and beyond. I'm Titus Seilheimer from Manitowoc, Wisconsin. I'm the fisheries specialist at UW Aquatic Sciences Center's Wisconsin Sea Grant and work in all things Great Lakes ecosystems and fish. Today, I'm pleased to introduce Julia Noordyk, who will speak on how communities across the United States are installing green infrastructure, nature-based practices designed to mimic the water cycle and absorb rain and snowmelt where it falls. Practices range from natural landscapes like floodplains and forests to highly engineered systems like bioretention, a.k.a. rain gardens, green roofs, and permeable pavement. This talk will show how your community can become healthier and more resilient by designing with nature. Julia Noordyk is the Water Quality and Coastal Community Specialist with the Aquatic Sciences Center. She has over 11 years of experience in community engagement on coastal resilience and water quality. Originally from Colorado, Julia found her way to Wisconsin by way of UW-Madison Nelson Institute for Environmental Sciences and moved back after a National Oceanic and Atmospheric Administration Fellowship in Maine to be closer to family. She loves the Great Lakes and working with communities to integrate nature-based designs that improve stormwater runoff, flooding, and public access. Please welcome Julia Noordyk.
Great. Thanks so much, Titus. I really appreciate the introduction. So let's get started here. So what you are looking at right here in this first slide is a green roof on the wastewater treatment plant of Port Washington, Wisconsin, which is located on one of the greatest water resources on Earth, Lake Michigan. This is considered green infrastructure as opposed to what you might typically see on a roof, which would be traditional infrastructure. So I work with communities like this one to overcome barriers and find opportunities for green infrastructure, or in other words, build with nature in mind. So what is that? So why don't we start a little bit first about why would we even want to change how we're building our communities? You know, we all seem to be going about our daily lives. We have neighborhoods getting built. Our wastewater gets whisked away, and there doesn't really seem to be a problem. But what we really have is traditional stormwater infrastructure in our communities, and it's really adapted to manage the stormwater. It really takes the rain off your roof, down the sidewalk, and into a storm drain. And we don't really think much about that. But when we concentrate it like this, we're really pushing our issues downstream. We're just getting rid of it, and there can be significant problems. What most people don't understand is that much of our stormwater that's coming off our roofs and our sidewalks and our parking lots is really going untreated into the nearest creek, river, or lake. And we're really having stormwater pollution issues. This is one of our bigger water pollution issues in our country. And you can see here, there's a lot of pollution happening. Some of the things we can see the dirty water. We can see maybe a plastic wrapper. We have leaves and sticks going down the drain. But there's also a host of things that we can't see that stormwater is carrying with it. We have, we have hydrocarbons from oils and leaks and drips from our cars. Our brake pads are producing copper dust that goes into our stormwater. That's really bad for fish and other aquatic animals. We have insecticides and herbicides coming from our lawns. We have many heavy metals going down. We have things like PFAS that are going in from our water supply, and really they can produce really contaminating things. In addition, since we're concentrating the flow and just pushing it off our properties, what we can have is unintended consequences in terms of quantity of water coming down too, in too short of a time. And so in many communities, particularly along the Great Lakes or in other communities with old stormwater infrastructure, we're having problems where all that water is just collecting and it has nowhere to go and really causing some flooding issues locally in our communities. So what can we do? Well, what we really need to think about is a new way to think about managing stormwater. You know, right now we're just putting it all down the storm drain into the gutter and out into the nearest creek. And instead, we need to go back to about third grade and think a little bit more about the water cycle, how water moves in our atmosphere and across our land in general. So thinking about how water moves in general. So it rains, it comes down, it condenses on the land, and then it runs off the land and goes to your nearest creek, river, and then eventually out to an ocean or a lake, so forth like that. On the way, it's stored, it's infiltrated into the ground, into our groundwater, or it's stored and then evaporates, or the plants uptake it and it's transpired back into our atmosphere. So really thinking about the hydrological cycles that really influence how water moves about on our landscape. And so that's really what we're thinking about when we're thinking about how to manage stormwater differently. We want to manage it as a resource rather than a waste, just trying to get rid of it. So this is the Menominee River Industrial Center Stormwater Park that was built with green infrastructure in mind. Now, this used to be the machine shop of the world in the 1800s and 1900s, and it was a brownfield site, very polluted in general. And they turned it into an amazing industrial park, 60-acre park, 60-acre industrial park that has over 14 businesses. And all of their stormwater moves through this incredible system, wetland system, that's designed to treat the water before it goes into the Menominee River. And so what is green infrastructure actually? Well, what we're talking about, it could be natural landscapes, like floodplains and your river systems and your forests and your wetlands and fields and things like that. That could be green infrastructure because it's soaking up that water. But in this context, what we're talking about today is really these engineered water management systems designed with natural features and functions. And so they're designed based on the hydrological cycle. Really, how do we capture that water, soak it into the ground, have plants uptake it, really slow that water back down rather than shooting it downstream in general. So what you're looking at here, right here, is a bioswale. So up in the upper part is the plants, and then you can see this engineered path where it's really trying to slow the water down. And then that bottom section is going to be planted with plants so that the swale itself, as the water moves downward down this hill, is infiltrated and the stormwater pollutants are filtered out in general. So these are kind of the principles that we really want to work on for integrating into stormwater management. And so one of the biggest principles is using native flowers and grasses. And you can see here that why. So we have Kentucky bluegrass. Much of our landscape is covered in grass. That Kentucky bluegrass, this is showing, the root depth of our root systems for these plants. And it's very, very small, just inches. Whereas some of our native species, like big blue stem grasses or blazing star, their root systems can reach up to 15 feet underground. So that is an amazing amount of infiltration ability and capacity for our systems. So we're really going to use the power of plants to actually store the water, soak it up from the ground, and get it into our groundwater. Okay, so let's talk a little bit about green infrastructure systems. We can put them, there's many different kinds, and we're going to start at like the top of our built environment, our roofs. And there are many applications in general. So green roofs really are putting plants on top of the roofs. We have a impermeable layer, and then they really capture that water. They infiltrate it, and then they use transpiration through the plants to go back into the atmosphere. They have enormous year-round energy savings for buildings because they provide an insulating factor. So in Wisconsin, we can insulate the building, and you can find a lot of energy savings just from heating and cooling the building. So when it's hot in the summer, the plants really take that heat and they cool the building down. And then in the winter, they provide an insulating factor and so forth. So the city of De Pere has found those energy savings from putting it on their city hall. They've also been used across Wisconsin in different environments to rejuvenate facilities, modernize buildings, provide an educational system place in general. And where I am locally in Green Bay, one of our hospitals has a public green roof. It's for their employees, but it's also for the public. It's for their patients, really supporting that interaction of nature and how that supports our health in general. And it's a really wonderful space. So really capturing that water. We can also, now going down the building, we can have green walls, kind of the same thing as a green roof, but you're capturing water as it's going down the wall and using it in aesthetic situations. You can have very intricate systems where, art meets the master gardener in certain situations, and really using that water as a resource to water your plants. This one is really cool. I found it's London's largest living wall. It captures over 2,600 gallons of stormwater, and it has 10,000 plants. And people have to scale it to take care of these plants. But it's really starting to capture that water, what otherwise would run downstream untreated. I think one of the most common green infrastructure practices people know about are rain gardens, rain barrels. So rain harvesting, just capturing directly off the roofs. But what most people aren't familiar with is we can actually scale that up to bigger sizes, to cisterns. So this one is on a viaduct in Milwaukee, and it's capturing 68,000 gallons of storm water and snow melt annually to reduce that pollution directly into the river. Oh, and you can see the water's coming down off the road and then going into those pipes and into the cistern where it's later distributed. There's other ways to do it on side of businesses or buildings in our downtown areas or our homes. So this one is capturing and actually using it again to water plants just on the side of a building. This is a really cool product that is homegrown in Wisconsin, and it is 7 rain barrels and a raised bed in one. And so these can be put on the side of a homes, and then you can plant your fruits and veggies and have a permanent source of water all times, and then also use that extra water with a hose to water your garden. In our developing communities, like on our sidewalks and things, we typically are used to urban trees, but these are particular trees that are meant to capture the water off our sidewalks. And this particular product allows the root system through modules to actually grow underneath. And so the tree can be healthy, it can be, and it can grow to a full size and actually provide even more benefits to the community rather than being restricted to just a little box. Bioretention systems are also known as rain gardens at a smaller level. There are depressions in the ground, and what they're meant to do is collect water from a surface area and then slowly infiltrate it or have the plants take it up. And so these aren't permanent waters, ponds or anything like that. It's supposed to, drain out within 48 hours typically at the most. And these can be put anywhere on the landscape, and they're very, very versatile. So this one is capturing water from a cul-de-sac. But they're also used as neighborhood beautification in general, and revitalization of our neighborhoods can really add aesthetic and greenery to our neighborhoods. There we have the Sisters of St. Francis up in Green Bay, who's very concerned about environmental stewardship as part of their faith. And they have been collecting stormwater off their parking lot and filtering it into this beautiful landscape garden for treatment. We have you can scale up. This is an outdoor classroom in Milwaukee, and it not only captures and treats and filters runoff, but it provides an outdoor classroom for all the students at the site. And it has become a place of learning where you can study, those biological and chemical processes outside and enjoy the nature, which used to just be an asphalt parking lot. Also really important for our communities in general, thinking about smarter development. So this could be typically a tree that was planted in a parking lot. It doesn't look too happy, does it? So thinking about how we could do this better, using the water as a resource, capturing it in the parking lots to actually treat it, but then also provide amenities to the parking lots. And where does everyone want to park under when they go to a parking lot? Under the tree, right? So thinking smarter about how we can manage water and use it to our advantage. Another really great green infrastructure practice, which does not involve plants, but really focuses on infiltration and water storage, are called permeable pavements. And these also come in many different products. They come in pavers, they come in porous asphalt, so forth like that. They really help. Oh, go back really quick, but you can see here it's raining, and on the traditional concrete road, the water is not soaking into the ground, but in that permeable pavement, there's gaps in those pavers, and the water is soaking down and infiltrating into the ground immediately at its source. Some of these can be placed in certain locations for example, to reduce nuisance flooding. Again, so the water's not concentrating and building up in our storm drain, but is going down immediately. And here's just a different paver product that we have. They can be placed strategically, so they don't have to cover the whole road, but maybe just in the parking lane or a bike lane or something like that, where you don't have to cover the whole thing, and where you can grade the water into. And then driveways. Driveways are a great place. So these are 3 Wisconsin examples. One is this grid-like where grass feature on the left in Green Bay, where grass grows through it. Extremely low maintenance, very durable. This one particular, over 20 years. We can do our alleyways with a strip of pavers. And then here's just a commercial a residential building in Superior that has done it in their driveway, again, pavers. And then also they can provide a lot of aesthetics. This one's on the UW-Madison campus, and a really beautiful patio that also has a major function to it too. And then one of the last ones I'll talk about is engineered treatments, wetlands. These are constructed. These are, these are basically constructed wetlands that you put in low areas, maybe where groundwater's high or there's wetland vegetation already, where infiltration isn't really possible. And so you're really slowing the water down and then also treating it with those plants before it goes into the lake. This is another example of a larger one. This one is just outside Ann Arbor, Michigan, and they've turned this into a 81 acre park. I'm standing on a trail in this picture, and you can really see what these is all engineered wetlands. It's to help mitigate flooding and reduce flooding, but it's also to treat that stormwater that goes downstream. And so this is a major community asset for Ann Arbor. And then I'll just mention a couple of things that don't require engineering, which we can do very easily. So replacing turf grass with native flowers. We looked at those root systems before. Where on our landscapes can we just put in a pollinator garden and really take away those short little root systems, and then really infiltrate that into there. And so these are just simple things we can do across all of our communities, whether it's our homes or businesses or our park systems. Thinking about also doing this specifically along our most vulnerable areas, directly into our waterways. Where can we actually restore and improve and buffer that stormwater from getting into our local creeks and rivers? And then growing our urban tree canopy. This one is one of my favorites. No engineering required. Plant a tree, 10 years ago. They have an immense amount of stormwater benefits, and they're one of the lower cost things we can really do to capture that water and infiltrate it up into the ground for our communities. And they provide so many more benefits in terms of reducing urban heat island effect and making cooling our communities, providing aesthetics, and really bringing nature into our communities. And so getting started is really easy. There's many different types of green infrastructure practices, and it really depends on what your community's goals are and thinking about how your green infrastructure can meet your goals. I kind of introduced you to some examples, but where in your community could you see the combination of treating stormwater, managing flooding, and then also having these amazing other benefits that the green infrastructure provides to the community? And that's it. I want to thank you so much. I'm happy to have people reach out to me if they have any questions about green infrastructure or they're interested in their communities to get things started and want to talk. So thank you.
Thank you for watching this Badger Talks live event produced by the University of Wisconsin-Madison through UW Connect's Outreach and the Office of State Relations. Follow us on Facebook and YouTube to see the library of past recorded talks. Please visit badgertalks.wisc.edu to see the schedule of upcoming talks, sign up for the Badger Talks email list, and search the roster of over 400 UW experts who are available to give talks on important issues in your Wisconsin community.